Rocks and minerals are all around us. They are the foundation of our planet, forming the very landscape we see every day. From the towering peaks of mountains to the rolling valleys and the sandy beaches, rocks and minerals are everywhere. They make up the mountains, valleys, and beaches of our planet. These natural formations have been shaped over millions of years by various geological processes, including erosion, volcanic activity, and tectonic movements. But what exactly are they? Rocks are solid, natural substances composed of minerals. They come in many different types, each with its own unique characteristics and formation history. Rocks are made of one or more minerals. These minerals are the building blocks of rocks, and they determine the rock's properties and appearance. For example, granite is a common rock that contains the minerals quartz, feldspar, and mica. Think of a chocolate chip cookie. The cookie is like a rock, and the chocolate chips are like minerals. Just as a cookie is made up of different ingredients, a rock is made up of different minerals. Minerals are naturally occurring solids with a specific chemical composition. They are formed through various geological processes such as crystallization from molten rock, precipitation from water, or changes in pressure and temperature. This means they are made up of the same ingredients in the same proportions. Each mineral has a unique chemical formula that defines its composition and structure. For example, the mineral quartz is made up of silicon and oxygen atoms in a specific arrangement. Each mineral has unique properties. These properties are used by geologists to identify and classify minerals. Some of the key properties include hardness, color, luster, and crystal form. These properties include hardness, color, and shape. Hardness refers to a mineral's resistance to being scratched, while color can vary widely even within a single mineral type. The shape or crystal form of a mineral is determined by its internal atomic structure. Rocks are constantly changing and forming in a process called the rock cycle. This cycle is a fundamental concept in geology, illustrating the dynamic and ever-changing nature of our planet. It encompasses the formation, breakdown, and reformation of rocks, driven by various geological processes. Understanding the rock cycle helps us appreciate the complexity and interconnectedness of Earth's systems. It starts with magma, molten rock found deep inside the Earth. Magma is generated in the mantle due to high temperatures and pressures. When magma rises to the surface through volcanic activity, it can erupt as lava. This molten material is the beginning of the rock cycle, setting the stage for the creation of new rocks. When magma cools and solidifies, it forms igneous rocks. These rocks can form either beneath the Earth's surface as intrusive rocks, or on the surface as extrusive rocks. Intrusive igneous rocks, like granite, cool slowly and have large crystals, while extrusive rocks, like basalt, cool quickly and have fine-grained textures. Igneous rocks are the foundation of the rock cycle, providing the raw material for other rock types. Igneous rocks can be broken down into smaller pieces by weathering and erosion. Weathering is the process of breaking down rocks through physical, chemical, or biological means. Erosion involves the movement of these weathered materials by natural forces such as wind, water, or ice. Over time, these processes break down igneous rocks into smaller particles, creating sediment. These pieces, called sediment, can be transported by wind, water, or ice. Rivers carry sediment downstream, wind blows sand across deserts, and glaciers grind rocks into fine particles. This transportation process is crucial in distributing sediment across different environments, where it can accumulate and eventually form new rocks. Over time, sediment accumulates and hardens, forming sedimentary rocks. Layers of sediment build up in areas like riverbeds, lakes, and oceans. The weight of the overlying layers compresses the sediment, and minerals precipitate from water to cement the particles together. This process, known as lithification, transforms loose sediment into solid sedimentary rock such as sandstone or limestone. If sedimentary rocks are buried deep enough, they can be changed by heat and pressure. This forms metamorphic rocks. Metamorphism occurs when rocks are subjected to conditions significantly different from those in which they originally formed. The intense heat and pressure cause the minerals in the rock to recrystallize, creating new textures and structures. Examples of metamorphic rocks include marble, which forms from limestone, and schist, which forms from shale. The rock cycle is continuous. It has no beginning or end, and rocks can transition between types multiple times over millions of years. This ongoing process is driven by Earth's internal heat and external forces like weathering and erosion. The rock cycle illustrates the dynamic nature of our planet, where rocks are constantly being recycled and transformed. Rocks are constantly being formed, transformed, and destroyed. This never-ending cycle is a testament to the Earth's ability to renew itself. By studying the rock cycle, geologists gain insights into the history of our planet, the processes that shape its surface, and the materials that make up its crust. The rock cycle is a powerful reminder of the interconnectedness of Earth's systems and the ever-changing nature of our world. Rocks and minerals are made up of elements. Elements are the basic building blocks of matter. Some of the most common elements found in rocks and minerals include oxygen, silicon, aluminum, iron, calcium, sodium, potassium, and magnesium. These elements are like the letters of the alphabet. Just like letters can be combined to form different words, elements can combine to form different minerals. Elements in minerals are held together by chemical bonds. These bonds are the invisible forces that keep the elements in a mineral connected, much like how glue holds pieces of a puzzle together. Without these bonds, the minerals would simply fall apart into their individual elements. These bonds are like glue that holds the elements together. Imagine trying to build a structure with bricks, but no mortar. It would collapse. Similarly, without chemical bonds, the structure of minerals would be unstable and unable to form the solid rocks we see in nature. One common type of bond is an ionic bond. Ionic bonds are formed when one element donates an electron to another element. This transfer of electrons creates a strong attraction between the two elements, much like the attraction between opposite poles of a magnet. In an ionic bond, one element gives an electron to another element. This electron transfer results in the formation of positively and negatively charged ions. These oppositely charged ions are then strongly attracted to each other, creating a stable bond. This creates oppositely charged ions that attract each other. The strength of this attraction is what makes ionic bonds so strong and effective in holding the elements together in a mineral. Another type of bond is a covalent bond. Covalent bonds are formed when two elements share electrons. This sharing allows each element to achieve a stable electron configuration, making the bond very strong. In a covalent bond, elements share electrons. This sharing creates a strong bond that holds the elements together, much like how two people holding hands are connected. The shared electrons act as a glue that keeps the elements in close proximity. This creates a strong bond that holds the elements together. Covalent bonds are particularly important in the formation of crystals, where the precise arrangement of atoms and the strength of the bonds result in the beautiful and intricate structures we see. The type of bond that forms depends on the elements involved. Different elements have different tendencies to either donate, accept, or share electrons, which determines whether an ionic or covalent bond will form. Understanding these bonds is crucial for geologists and chemists as they study the composition and formation of minerals and rocks. Granite is a common igneous rock. It is formed when magma cools slowly beneath the Earth's surface. Granite is made up of the minerals quartz, feldspar, and mica. These minerals give granite its characteristic speckled appearance. Granite is a hard, durable rock that is often used for building materials, countertops, and monuments. Section 6. Common rocks, basalt from volcanoes. Basalt is another common igneous rock. It is formed when lava erupts from volcanoes and cools quickly. Basalt is typically dark gray or black in color. It is made up of minerals such as plagioclase, feldspar, and pyroxene. Basalt is used for a variety of purposes, including road construction, building foundations, and as a source of crushed stone. Section 7. Common minerals. Quartz, the versatile mineral. Quartz is one of the most common minerals on Earth. It is found in a wide variety of rocks, including granite and sandstone. Quartz is made up of silicon and oxygen. It is a hard, durable mineral that is resistant to weathering and erosion. Quartz has many uses, including in electronics, glassmaking, and as a gemstone. Section 8. Common minerals. Diamonds, sparkling treasures. Diamonds are the hardest known natural mineral. They are formed deep within the Earth's mantle under conditions of extreme heat and pressure. Diamonds are made up of pure carbon. Their hardness and brilliance make them highly prized as gemstones. Diamonds are also used in industrial applications, such as cutting tools and abrasives. Section 9. Unlocking Earth's secrets. Why it matters. Understanding the chemistry of rocks and minerals is essential for understanding our planet. It helps us to understand how Earth formed and how it has changed over time. It also helps us to find and use natural resources responsibly. By studying rocks and minerals, we can unlock the secrets of Earth's past, present, and future.